years ago, in December 1972, the last time a human being has stepped a footstep on the moon. And I've met this person just 2 weeks ago. And Harrison Schmidt is his name, is the last one still alive. And he gave us a lot of good hints and tips, his own experience, how it was on the surface of planet Mars. No, moon. But the plan is to go to the Mars from the moon. So first go to the moon, make a moon station like the ISS around the Earth, around the moon, which is called Gateway. This will be done with Artemis 3. By the way, if you ask yourself, before in 1972 these missions were called Apollo. And in Greek mythology, Apollo and Artemis, they are like twin sisters. Well, you know, sister, brother, and so on, you know, but twins. So Artemis will be the mission for the first women on the moon. Europe is contributing to this mission with the Orion capsule, and this is within the SLS, the Space Launch System, which is now in Cape Canaveral, starting to the moon. And the life-saving module is built in Europe, and is a contribution to this mission. And for this, even some European astronauts can join this mission to the moon. This is wonderful. I think it's good. From the moon, they will land with a 50 meters rocket to the surface of the surface of moon, from the moon orbit to the surface of moon. And the plan is make an international lunar research station. And for this, you need an international lunar research team. And I'm a member of this team. But I hope to see many young faces here to be members too. Please, do your best to be excited about this. And even if you think now that you may not be ready, but if you learn enough and look for the things, for the details, the little things, you may be the next one.
I promise.
You understand? The next generation is very important. So please listen to me and join us, because from the moon there will be the start to the Mars, and this lunar station will be in the southern area, the south pole of the moon, which is like Atkins and Schrödinger crater, and this one is not too hot, not too cold. On the moon you have like 14 days, 14 Earth days is the length of a moon day. And the moon night is also 14 Earth days. Can you imagine? It's like 2 weeks on Earth is 1 day on the moon?
Yes.
Wow. But if you get 14 days of straight sunshine on the moon, it's going to be very hot. Therefore, we decided to have a moon station in the shade of the South Polar region, because in this one, the sun is not shining so strong. And the sun is dangerous, because we on Earth, we are protected by the magnetic field, which is produced by our, volcanic activity inside the Earth. It's like on a bicycle. You have a solid nucleus and then some liquid stuff, and outside it's solid. This is the solid stuff we're standing on. And if this is moving, then it produces a magnetic field around. So if you have a light in your bicycle, it's also produced the same way, by induction. And so it's one of the principles of natural science. And the moon doesn't have this system anymore, because the moon is so small, it has cooled down. It's not liquid inside anymore. The Mars, this Mars, it also was with a magnetic field. and it had volcanoes, but no more. It has cooled down. And we could even see the traces of the last volcano erupting. And the question was it still with a magnetic field or not? And the answer is, given at the end, if you ask me. It is interesting. So now, I come from the Leibniz University in Hanover. Leibniz was a great scientist, and this is an old building. Looks beautiful. It was built for chemistry and always used for chemistry. It's more than 100 years old. And it's in Germany the oldest building which has ever been used for chemistry. There are some older ones, but they have been used for other things as well. So, you know, this is the castle. It's a little bit bigger. It's a British-style castle. And of course, this is the office of the president. I mean, the president, you know, has a bigger one, you know. I mean, you know. Actually, it was built by the King of Hanover, because the King of Hanover, for a long period of time, actually from 1714 till 1837, the King of Hanover have been the King of England at the same time. King George from England was born in Hanover. When he was appointed in 1714, he couldn't even speak English, just German. But still he became the king. And he's still buried in Hanover. But he was Protestantic, that's why they selected him. It's a little, maybe a strange reason, but what can you say? So anyway, so that's why they still have like a British-style castle in Hanover. And when the Prussians came, they destroyed the kingdom of Hanover and said, oh, but this castle is nice, maybe it's useful for a university. So that's how we got it. And that's why the president's office is in here actually. If you can go in here between the lions and then knock at the door of the president, and maybe if he's willing, he will open it. Okay, this is Mr. Leibniz. And he did a lot of great things. So, and his name is the name we use here in the university. He died in 1760 and was born in 1646. And actually, he invented these numbers, these 101, the binary numbers, which we use in our computers, in our mobile phone. At that time, when he discovered it, people told him, this is not useful. This is a garbage. We don't want to publish this. But nowadays, everybody is using it in the computer. But at that time, nobody had a computer. So he built the first binary computer. A mechanical one. Mechanical one. And we still have it in Hanover. And actually, he has written 200,000 pages. And they're still preserved in Hanover in the Gottfried Wilhelm Leibniz Library. And it's a UNESCO World Heritage. And he has even built other calculating machines, which are outstanding. So if you have a chance to come to Hanover, please see it. You can do everything out of nothing and one. And we use this. This was the original publication. It's just like a letter written, and he has like 200,000 of this. And we use this part as the logo of a university. It's amazing. It's so lovely. So 1 is a 1, and a 10 is a 2, and a 100 is a 4, and a 101 is a 5. So you can do all these calculations with the binary numbers. So this is the decading number, the ones we use. You have like 10 symbols from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 10 symbols. But in the binary, you have only 1 and 0. So you get a 2 in the decadic, you need a 1 and a 0 in the binary number system. But this... Okay, somebody is asking some question? No, maybe not. And so that means, so this was very useful because you could have a cable, and the cable could have a current, and it is 1, or no current, and it's a 0. Or maybe voltage, 5 volts, or 0 volts. So something like this. This was used, and this is the way the computers work. But the computers of the future will probably not work with electrons anymore, which have this 1, 0 states. But they have more than these 2 states. They will have thousands of states. These computers may be much faster than that. And such computers may be done by light. And these are crystals. I'm a chemist, and I make such crystals. And such crystals, if you shine light on such crystals, these crystals can change a color. You see, you can change a color. And we can make such crystals in my lab. And such kind of things you can use to make new computers working with light. And this will be like a quantum computer. Some people call the one with electrons a fermionic computer and the other one a bosonic computer. But it's a different story, I'll tell you another one. Now I have a riddle, which I will answer at the end of my talk. You know, I love chemistry very much. But there is one element among, you know, chemistry is like playing Lego. You have little elements, bricks, and you put them together to make big things. And you take them apart to get smaller ones, and do it again. But the only big difference is that the elements in chemistry are a bit smaller. So I don't see them with my eyes, but still I can connect them without seeing in a chemical way. These are the tricks what the chemists are doing, connecting atoms and separating atoms. Not more than this, that's all. It's true. You can see if the oxygen is connecting to the iron in my hemoglobin, it changes the color to red. You look into my face, it's red. If the oxygen is gone, it will be pale white, no color. Amazing. Anyway, which element is the one? One of these chemical elements, you know, hydrogen, oxygen, nitrogen, iron, copper, silver, gold, platinum, whatever. You know, we have a few of them, like round about 90 stable ones. Would you make an artwork which is taller than 100 meters? Or would you found a society for an element like this with more than 100 million members? And I ask you whether you would do, or whether maybe you know already one society on Earth which can do. If you have an extraterrestrial one, it's okay too. I accept even extraterrestrial answers. Since I have touched something which is on the Mars, I feel like I can do it. Okay, please think about it. At the end of my talk, I will give you the answer. Now, the Mars.
Finally.
Here's the sun. It's a star. It's burning hydrogen by fusion to helium. And then it can burn further and further and further. It will end up around iron. And this will be the end. But it will take another 11 billion years. So don't worry today. So the sun will still burn. It's a huge fusion reactor which gives us enough energy to survive. And a little bit further up is the Mars. But Mars, to go one time around the sun, takes round about 2 Earth years. Double the time. So when the Earth has rotated one time around the sun, 1 year, 1 Earth year, the Mars is only at half position. Then it takes another year of the Earth until the Mars is back. So every 2 years they're passing by. That's why it's very easy every 2 years to jump from the Earth within a short period of time to the Mars within only 7 months right now. If we can manage to take some other kind of fuel like antimatter, maybe we can do it much faster. But this is a different story. I'm talking about right here and now, and how we did it and how we're going to do it tomorrow. The Earth, the day on the Earth, it's a rotation around its own axis of the Earth. And when the Earth is rotating one time around this axis, it's 24 hours, it's an Earth day. On the Mars, the same thing takes 24 hours and 40 minutes. 24 hours and 40 minutes. So that means you can imagine NASA working in Martian time. So if I start working today at midnight, tomorrow I have to start working at 0:40, like almost 1 hour shift of my working time. And the next day is another hour and another hour. So every day you refresh your jet lag. So you feel like you have one of the best jobs in the world, but you feel like you're always kind of like tired.
And there is
Because
the
you are.
temperatures.
That's the reason. Now here, this was the first landing, successful landing on the surface of planet Mars in 1976 with the Viking 1 mission. There was even a Viking 2 mission. And then we took some pictures, mankind took some pictures, and we got the blue sky. But you know, how do you get a black and white camera to produce color picture? So you mix with different filters some pictures, and with these ones, you are having, well, assumed it's a blue color, but it's not true, because in 2005, you see it's a red. It's just they changed it that it looks blue. So it was a false color picture. And this is a true color. And this is the rover, so you see the solar panels. This is the Mars Exploration Rover Spirit. And there is another one which is called Opportunity. And here, down here, there's a little robotic device, an arm. And there are two devices, and there's the one I am responsible for. Yes, so if you ask me what I'm doing here, I'm working with this one here. So, but here you see the tracks on the Mars, and if you see the metal here, these are the tracks here on the stripe. So they look like here, this pattern. You see, it's all from the Mars. Okay, now this is the sunset. The sky is red, but the sunset and sunrise is blue, greenish blue. Amazing. And it's all because of these particles in the cloud. These particles, dust, iron dust cloud particles, they absorb and give them red color and change it when the sun goes down. On Earth, you have liquid water, you have rain. But on Mars, the pressure is 100 times lower than on Earth. And that's why liquid water is not available, not possible. You have frozen water on the northern and southern pole of the Mars, but for liquid water, so that water can be solid and go to the gaseous, but for liquid state, you need a higher pressure. But in the past, there was a huge amount of liquid water, and the pressure was higher. And we found out why and how, and why is it not anymore in the course of this mission. Now here we started with Spirit, and 3 weeks later with Opportunity to the Mars. And this Spirit was called Rover A. But it also had another name, Rover B. No, Rover 2. And actually, you know, there was a big problem. So at NASA we had like the names like A and B for the two rovers. And then the NASA boss said, oh, you have to change the names. A and B is not such a good name. So the scientists were thinking and said, oh, we call them, the rover A we call 2. And the rover B we call 1. And that's what we did. And then the NASA boss said, Jesus, why didn't you have some, couldn't you? And then he said, no, I have to go to the smart kids to school. And they made some competition. And all kids could send him from everywhere on the earth, could send their suggestions. What should be the name of this rover?
Yeah, I know.
And many suggestions arrived at NASA headquarters in Washington, D.C. And then one 8-year-old girl went on stage shaking hands with the NASA boss and telling, with the right spirit, we will have the opportunity. And from then on, the two rovers were called Spirit and Opportunity. What a story! So, if you didn't see it, maybe you missed your chance to submit a name for this mission. But I tell you, There are some upcoming missions. Look and check at the NASA homepage and see where is the next competition, and you can contribute. There are even some, there are even some competitions for missions to the moon, to the Mars. Even now, for the next mission, you can submit your name and your dates, and they will be stored on this vehicle and sent to the Mars or to the moon. So you can do this for free, and you get a card, like a ticket, that your name and so on is there. And this is for free. You can do it for free. It's a nice gift, and even it looks good. I can tell you, I did it. But these are the Delta II rockets from the Boeing company. In here, there's the rover doing this, and it was working nicely, and he will land it on the Mars. And we have been landing. There was Viking 1, Viking 2, from 76, which I've told you. And actually, on these three, the Spirit in the Gusev crater, an opportunity here in Planitia Meridiani, and here was a Beagle. That was a European-British joint mission. And also here we had our device, but unfortunately this one was not tested well enough. It failed. We have never heard again from it, but we've seen it from space. Now there's the Perseverance rover working here, and the Curiosity rover, and now this is collecting samples in tubes, small titanium tubes, and they will be picked up by the next rover mission and sent back to Earth, and we are invited to investigate the samples and do some measurements with it here on Earth. I'm really looking forward to getting these wonderful samples. But we have to see, actually this was a Pathfinder mission. Who has seen the movie The Martian? The Martian. Oh, on this Martian, there's one device on the little Sojourner rover on the front, measuring the elements, which was built also from our group. And it worked very successful. And the Martian, he saved Mark Watney. He saved his life by picking up this small little Sojourner rover and making contact to Earth. So Hollywood has already used these things. It's wonderful. Also, maybe who knows the Big Bang Theory? And oh yeah, great. Now, Big Bang Theory, they actually in one episode they captured our rover. And we're driving on the Mars with our rover. Amazing. And the Big Bang Theory, this NASA headquarters for our Spirit and Opportunity mission, also for Perseverance and Curiosity, also for Pathfinder, is the JPL, the Jet Propulsion Laboratory, in Pasadena. And it is connected with who it is connected with? With the California Institute of Technology, Caltech. And the guys from the Big Bang Theory, they live in, where do they live? They live in Pasadena and Colorado Boulevard. They have their flat in the movie. But when I'm there in NASA, I live also on the Colorado Boulevard. But me, for real, they just in the movie. But when they go to the university, the guys from the Big Bang Theory, they go to the Caltech physics department. And they go there in the movie, and I go there real. So, you see, that is the difference. Now here, that's how we landed with the airbags, and this is original pictures on the way down, and this is the rover. Here, we all started to cry in the mission control room because we got the first picture like this from the Mars, and it was so wonderful. Because before, on the landing, we had like 10 minutes, we expected a signal, but there was no signal, and we thought, oh Jesus, maybe it has crashed. Oh, ah. And then we have the Deep Space Network on Earth, who is listening to the signals from the Mars, and they send it. You have one in even Europe, next to Madrid, there is a big antenna. And then you have one in Australia, Canberra. And then you have Goldstone, California. There's also one in Kagoshima, Japan. But this Deep Space Network, they send the information to the NASA, and then we can use them. And actually, so we were in the mission control, and we didn't get a signal, and we were hoping for the signal. But after 10 minutes, we saw, like somebody saw a spike on the screen. You can imagine the tension. There was a spike on the screen, and people said, oh, and then everybody said, oh, but it was nothing. It disappeared. But then, Goldstone is a big antenna, and a little bit like 100 kilometers north of it, or not too much more. Also in California, there's the Stanford University has some observatory, and they saw, we get the signal of the rover. Everybody was looking, the big deep space network is not getting the signal, but they claim to hear that. I'm not sure if this is true, but suddenly Goldstone confirmed the signal of the rover. Wow. And then we were all crying. And when we got this picture, we were just so excited. And the reason was the rover landed so upside down, just as I've told you at the beginning and showed you. But it could open like a flower, and then it was on the top. And these three antennas, they sending signals directly to Earth. This one sending to a parabolic antenna, and this one sends it to the orbiter. And it comes by every 2 hours, getting the data for around about 15 minutes, and then send them on to the Earth. And the problem was, we only were looking for one of the poles. And we should have looked for both. Maybe then our precision would have been better. But this one was sending the message right into the soil of the Mars. So the landing was really the worst situation you can imagine. But nevertheless, after the rover rotated around, and here it's on halfway, he's just opening, opening here this tetrahedral structure, which you have seen before, then it came up like that. And then we could measure some, this was the crater it was landing in, the Eagle crater, and we found some minerals which we have been looking for, like a jackpot. There was the proof for liquid water on the Mars. And here we see the rover sitting there. And these are these kind of minerals with some microscopic imager we've measured. And then we were trying a lot, more than the distance of a marathon on Earth. This side is the better one. And you see here, this is the IDD with the 4 devices, the 2 of them are ours. And this is a crater which we have survived to dive in and come out. There's another huge story which I have not time to tell you, but this is Spirit and Opportunity. It's like 140 centimeters tall, and also from here 140 centimeters long. And here, these 2 devices, they are the ones. These 2, they are made in Europe. And here is alpha proton X-ray spectrometer to see the elements, and this is the Mercer spectrometer to see only iron and its minerals. Tell you the history of it. And since this iron is one of the most stable elements in the universe, it tells you a lot about it. There's a microscopic image of this side, and there's a rock aberration tool which can polish the surface. Now here's also some magnets in the front, and this is a sundial. Sundial, what do you need a sundial for? It's a very ancient way of measuring time, but just getting the shade of the sun. But it was very important for us. And if you want to know, ask me the questions after my talk. Now, here you have the peeling stuff in the front, and here we have 2 cameras for a panoramic camera, PanCam called, or navigation camera, NavCam called, and they are at a distance, a certain distance, and this tells you how many centimeters they are apart, how much you can look in 3D at what distance. So we can precisely calculate how far you can see 3D with your eye. Anyone has an idea how far you can look 3D with your eyes? When they're like, how much is the separation, like maybe 10 centimeters or something? How much? What do you think? How many meters you can look 3D? Give me a guess. Who has one idea?
Maybe
500 meters. There's 500 meters. Who thinks it is more than 500 meters?
Is it like a couple of kilometers?
You say maybe a couple of kilometers. So who thinks it is less than 500? How much? 100 meters.
about 50.
About 50. Okay. 10. Okay, the answer is, you can calculate it precisely. The answer is really, when you break it down, make some small assumption, roughly, for each centimeters you can see around about 1 meter 3D. So it's like, the answer is like 10 to 20 meters in average, round about. 10 to 20 meters only! So that means I cannot see you like here in 3D anymore. Yes, this is true. So I have a friend, he took a, you know, there was a beautiful fireworks, and he wanted to have it in 3D. So he had 2 cameras, and it was like, in a distance, we had the cameras in a distance of 1 or 2 meters to get it in 3D. So that's why, please, you can calculate all these things. A little bit of math helps. So, you know, our way of thinking has some universal language. It's called mathematics. And you use the mathematics to just code down your thinking. And then you can just make some formula which takes you 1,000 years of thinking, but just writing a little bit of this formula. So it's a very efficient way of writing, and we can make such results which I've just told you. Anyway, these are some magnets. We can see the magnetic parts and so on. So this is our little device, the miniaturized Mössbau spectrometer, MIMOS. And here you see, that's it. I have it in my hand. It's really handy, it's small. And here I am with the rover at Cape Canaveral, but that's a different story. Here it is at the JPL, here mounted at the rover in Rio with the suit. And this is the first measurement on the surface of planet Mars. The first one which has been measured outside of Earth with this method. And we see there is iron, oxidized iron, which is this one. And that is less oxidized iron, which is iron-free, olivine. So if you have a green bottle of wine, then it's iron in these kind of silicates, which is olivine, if you want to see the color of it. But if you think it's iron-free in some silicate, then look at the brownish beer bottle. It's also iron-free silicate. So, but you see there's more iron too, 60% than to the total. So there is more iron not oxidized than the rest. But the oxidized one is like this brownish reddish, so the reddish surface on the Mars, it's a red planet. But it's only a very small thin layer of iron oxide. The rest is not oxidized. By the way, this olivine, if it's grown nicely, then it's called peridot. It was the favorite stone of Cleopatra, the ancient queen of Egypt. But you know, she was Ptolemaic. She had some migrational background. She was Greek descendant from Alexander the Great. So she was not the original Egyptian, but still she was the Greek. And still she loved the stone. So who cares? Anyway, this is a different story. Now here you see, sorry, this was the wrong direction, but now here you can find such magnets even here in some bacteria. And this kind of bacteria, Magnetotactica, they survive because of the magnets. They can orient on the magnetic field on the Earth. If they go too close to the surface in the water, they die because of too much oxygen and sunshine. But if they go too deep, they die because they die of starvation, don't get enough food. So this magnetic field is very important for them. So iron is very important. When you have inside the planet some liquid, solid iron, then getting liquid iron, then it becomes like this pyroxene and olivine. And when it comes out as a lava, then you can, if there is enough oxygen, be oxidized to lots of different minerals, goethite, hematite, or green rust. If there's not enough there, green rust, lepidocrocite, magnetite, magma. So many things, and we can measure them with our machine and tell you. You can read the textbooks, the geological textbooks, and use them. And this was one of the most important results. We found this mineral here. And the most important thing on this mineral is this hydrogen here. Because this hydrogen means there's hydrogen in. And if there's hydrogen in, the hydrogen is the smallest element we have. But it's moving so fast it can escape. when you heat up to 800 degrees and above, it disappears. But this we call a molten state. That means, since it is still there, it was always below this temperature. So that means it was produced in a liquid. This is the only way. So this was produced in liquid water. And we can tell you more. Because of the sulfate, it was produced in acidic liquid water. And I can even tell you what pH it was. Like our stomach, pH 2, but not in the stomach. It is pH 2. It is acidic for digestion. And it is HCl acidic, so hydrochloric acid. So the salt you eat, the acid you produce, but this is a sulfuric acid, so it's a different one. And we can now even the upper one, which is pH 4. And this pH 4, because involved, it will create some other things like goethite. But we didn't find the goethite there, so it must have been produced between pH 2 and 4, and it was liquid. And since we found this over the whole area, we could claim the whole area was underwater long time ago. The Mars was a blue planet. And here, there is another proof for the sulfur with the other machines. We could confirm this. We also found some little berries, and we could nicely see that they consist of iron oxides. And now, the iron, it can be produced from molten state, liquid. No solution, only above 1000 degrees. Usually iron melts at 1536 degrees Celsius at ambient pressure. If you change the pressure, you also change the boiling point and the melting point. But if this is the case, you get such things like this. But if it's in water, you have the hydrogen connected to it. And then you can get this geroside. And this geroside was like spectacular. Like newspaper guys called me up and said, "Oh, please tell me what is the result." I said, "I go to jail for 10 years in the US if I tell you before they tell it on TV. I'm not interested in going to jail just because you want to have a nice headline in the newspaper." So, yeah, so he wrote that Professor Renz was telling that we found some iron oxide on the Mars. I said, "No, that was not quite true." Anyway, that's a different story. So we found it and it was so lovely. And now you see the Mars is now red, but it has, by the way, the Phobos and Deimos. And right now, we actually tried to fly to the Phobos in 2009. Unfortunately, the rocket failed. But we're back again. We're trying to go there again. With a Japanese-European mission, the MMX mission. And they just told me last weekend, we'll get samples back from the Phobos. This area, actually here we wanted to land, exactly here, in this crater. And then when these samples coming back, we can investigate them. And then also, you know, that the Japanese, they managed to do great stuff. They managed to fly to an asteroid, take a sample and bring it back to Earth for the first time in mankind's history. In 2010, 12 years ago. But this year they did it again with the Hayabusa Mission 1 and the Hayabusa Mission 2. And they just sent the samples to Berlin so that we can measure them. And I'm very excited to get the results. And you know how did it send them? You know, these samples very precious because on Earth you can buy them nowhere. You have to get them from space. You know how they send them? By DHL.
Are you kidding?
I was shocked. I was shocked because I've lost packages with DHL.
Are you serious?
Not this one. But I told the Japanese, "You really believe in people." Thank you. The Mars was a blue planet, and it's no more. Why? Because the volcanoes were lost, but the sun winds coming with 400 kilometers a second, and they bombard the Mars. just as they did bombard the moon. That's why the moon's mineral, we have more than 380 kilograms of moon rocks on the Earth. I have in my office some moon. So, if you visit me, I will show you. But I have some other sample, which my good friend Wolfgang picked up from the deep sea. 6,000 meters deep in the Pacific Ocean at 600 bar pressure around and 40 degrees Celsius growth. This beautiful little compound. If you want to see it, maybe you have time to see it afterwards, or maybe Wolfgang can tell you about it. So there's another mission, and this is very spectacular, but I don't have time to tell you about this exciting stuff again, but you can imagine. Now, the magnetic field is stopped, and the pressure, because the volcanoes, they blow out gas, and then the pressure goes down, and therefore, there is no water. The pressure goes down, and liquid water, was not stable anymore. And the question is this also happening to Earth? Or what is the other question? How can we avoid it? And there are several ways. Now that we know what happened to the Mars, we can try to avoid it for the Earth. Now, you see, we had planned for this mission 90 days. 90 days. But in total, we have made more than 5,000 days. More than 5,000 days. Instead of 90 days. Why? Because we were extremely lucky. And we, after 90 days we had no money, but they had to shift some money to the SLS program. So they needed some other results, and this was cheap because it was going. But the problem was the dust on the solar panels were killing us. And these dust devils, we were afraid if they hit the rover, they may kill the rover. But instead of killing the rover, they cleaned the rover. And we called them cleaning events. And you see, this is the sun cowl, covered with dust. But after the dust devil, it looked like this. So this dust devil saved our life so that we could do more than 5,000 days. And here you see the rover full of dust. And now, it's a selfie made by the rover. And now, after the dust devil, so before and after the dust devil, so we cleaned the rover nicely, and then we could get a lot of energy because the sunlight would go to the solar panels and produce power to survive. Now we were walking like a breakdance, we were walking. If you want to know why, ask me afterwards if we have some time. Now, this is the first press conference, and this is first time. Who is the second generation of this machine? I'm the third generation, and the first generation was Professor Kankerleit in Darmstadt. So these kind of things, these space missions, they go over generations. So we need the next generation. Please listen up, young guys. It's your turn. This is Professor Mösbauer. He received the Nobel Prize for his PhD thesis, for finding out this effect. With this effect, the Mösbauer effect, you could measure for the first time relativistic effects at room temperature and ambient temperature and small speed, not close to the speed of light. Usually you see relativistic effect close to the speed of light, in this case because this method worked so well. So here, I am a little bit younger than before. But you know, time is passing by. So the next generation, watch out, please. Be excited. So this is me at the press conference, and I was explaining the first spectra of, and we found again the stuff which, Cleopatra light and the other things, and even some magnetic phase. And then we could publish it nicely too. By the way, this is the scientific chief, Steve Squires of this mission. Very nice gentleman. And here, this is the guy who signed the check for the money. He was the vice president at this time with Clinton, but unfortunately then Bush did win the other election, so he did not become the president of the US. But then he got the Nobel Prize in 2007. Right now he's in Egypt with the President Biden, and they're talking about the future of the Earth. This is my NASA passport, so if by chance take this to Europe, 10 years of prison they promised to me, so I didn't like to take it, so I left it there. You can imagine. Now, we use this kind of machine also for other things like this. there's a picture, some people say, oh, this could be worth millions, because a painter who did also this picture, which was on auction, becoming one of the most expensive pictures at that time. Becoming the most expensive painter ever being on auction. But now it's a Leonardo da Vinci, which is for like around about 400 million, but he's still in the top range, like, There's also this picture, the kiss.
The kiss was named.
There, you can see, and the guy's name is Gustav Klimt. This is a Japanese version, if you like it, or this was actually more than 100 millions, actually 140 million dollars and so on. Or Hyako Yonshu Roku Okuen, if you want the Japanese one. Just for take, I don't know, maybe, And here we did some measurements, and actually there's some TV, but I'm short of time, so you want to have some questions. So this was on TV, and they liked it very much, and me too. But so there were several things on TV. I've been actually also recently on the Bulgarian national TV. So if you want to see it on the homepage, have a look. And I've been telling about such things as well. And also, this is in Japan. So the Japanese got interested in these things. So we worked on some Japanese major scientific instruments to get something on it. And I also got to the parliament of Lower Saxony with this device, because we found some treasures from the Romans on this field. And the history of Hanover is like 1,000 years old, but now this Roman camp is like 2,000 years old, so we could double the age of this. And here we found even golden coins on a just regular field like this. Everyone could go there and collect the golden coins. Nobody did for 2,000 years. So we did it. and we want to save it, but still some other guys say, no, we want to use it for industrial purposes. We want to use the rocks for building houses and so on. So we went to the parliament, and they're still deciding upon, so since 2019, so you see. Now we come to the riddle. The chemistry. Which element could it be?
Oxygen.
Carbon.
Oxygen. Carbon. Do you have
Hydrogen. Oxygen or hydrogen?
Oxygen. I hear oxygen. I hear carbon. Iron. Somebody said iron. Is this ironic? No, it is iron. This is true. Iron is true.
Really?
Iron is true. But how iron? And I'll tell you. The huge artwork of the iron is this one in Brussels. Each of these balls is an iron atom. And they are forming a cube in the center. And this is the crystal structure of the iron at room temperature. Of alpha iron. And for this iron, a huge society was founded. And this society is the European Community. And they did it for controlling the iron with the carbon, making steel, making weapons, making war. Because no iron, no weapons, no war. And it worked. We have the longest period of peace in Europe ever. After this European community was founded. Before, we always had a war in between. Big wars going on. But the First World War, we tried to cover it up, but we failed. After the Second World War came, and then we have the United Nations, but you see there is still another war, even with the United Nations, because some people, they just blocked the United Nations and it doesn't work anymore. But that worked not to have war anymore. Instead, the French and the Germans, who did fight the most in Europe, they worked together on one table and do great science, going to space or somewhere else. That's a nice future, I believe. And this is what we should keep in mind. Therefore, if somebody's leaving the European community, like somebody on the island did recently, they wanted to have another war in Ireland, Northern Ireland, and it's already coming up again. They forgot about the peace it brought to Northern Ireland and Ireland. They forgot about this and just were lying around on the street. Oh, they take so much money from us, but they were just lying, bloody liars. It's amazing. It's amazing how people behave. But please remember this, because it really worked for the longest period. And I think we should be happy about it instead of talking about these little things and so on. There are many liars. You know, in the internet, the lie is distributed 4 times faster than the truth. And that's why many people just hear the lies and don't wait for the truth. And this is a problem. You know, some idiots telling you should inject some disinfectant to your veins. And many people died because they listened to this advice of some idiotic president who was not trained in any medical information. So he was just
The same idiotic president that
this kind of
decided
things,
to
please,
drink
believe the
bleach.
people who know things and don't believe the others. So, get your own information, train yourself, and then you can decide yourself. This is what
Just
you
saying.
want. This is what I love to hear. Okay, we want to go back to the moon with our device, with Artemis. And with this, I tell you, this is the president, or was the former president of the university, and then he invited me to say welcome to the students, and I did. Welcome to the student. Yeah, the student enjoyed, maybe. But the next year, this is me. And this is student. You see? So things are fair, sometimes. Okay, I'm trained, I have some black belts in some martial arts, and I do such things as you have seen, and I train the people. And I like to use the iron symbol for this because it's associated to my name. And with this, I want to say thanks to all of you. And this is the name of